Okay, so this is the refrigeration cycle. So one important thing to know about the refrigeration cycle is why the properties of the refrigerant and why they use refrigerant in refrigeration. And that is because there is a pressure-temperature relationship in refrigeration, in refrigerants, and it's operating off of the heat of compression. Whenever you take a vapor and you compress it into a smaller space, there's friction of the molecules inside that vapor, and that friction causes heat, and it causes the heat causes it to move, causes them to move even faster. So the faster they are, so they move, the hotter it gets, the more pressure that the refrigerant or the vapor exerts on the container that it's in, and we measure that in pounds per square inch, PSI. Okay. So we have a compressor. It's going to be the first thing. Put the compressor right here. And basically the compressor has an intake valve and an exhaust valve. So it's going to pull in from the evaporator, and the evaporator is just a coil. Let's see. We'll make this one. Okay. So the evaporator is just a coil. So it's going to come in from here. So this, at this point, is 100% vapor. Remember that you cannot compress a liquid.
No.
So it has to draw in as a vapor. So this compressor is going to pull in 100% vapor, and it's going to pull it down in here. Okay. It's got a piston in it that's going to push up, and it's going to compress it. There's a spring on this valve right here. Each one of these valves are springed. Okay. So when you get enough pressure in there, the heat of compression is going to cause that vapor to warm up, pushing it into a small. Your pressure is going to increase. Okay, and once you get enough pressure to overcome that spring, boom, you come out as a hot gas. Okay, so you come in 100% cool vapor, you come out 100% hot gas. Okay, now at this point, this hot gas, it's going to go into your condenser, and what your condenser is going to, it's just a coil too. Usually has a fan blowing air across it. Okay. So as it's going through this coil, and you've got a fan blowing air through it. Okay. It's going to be cooling that hot gas down. And as that hot gas, now your pressure at this point is going to remain the same throughout the condenser. Your pressure is not going to change.
Okay.
The only thing that's going to change is the temperature. So when that gas starts to cool down, it starts to turn into a liquid. It starts changing state. Okay? And what it's doing is that fan is taking that heat energy out of this hot gas right here, and it's blowing it out into the air. So you've got warm air coming off of that condenser.
Yep.
And it's taking that heat out of the condenser. Therefore, this gas is getting cooler and cooler as it goes. So now, by the time it comes out of the end of the condenser, it is 100% warm liquid. Okay? So it's not cooled yet.
No.
But you've taken about 30 degrees of temperature out of that hot gas,
Yeah.
and turned it into a warm
Warm
liquid.
liquid.
Okay? And so that warm liquid is going to feed your expansion valve. And your expansion valve the purpose of your expansion valve is to meter refrigerant to the evaporator.
Yep.
Okay? Now, what we use in ice machines is thermostatic expansion valves.
Yep.
So it's got a little valve inside of it. It opens and closes according to the temperature of the suction line. So it's got a bulb. It comes up here and attaches to the suction line. So it's measuring your superheat.
Yep.
Okay? And the superheat is just the amount of heat that is above the saturation temperature of this vapor.
Yep.
Okay? So once it becomes 100% vapor, then it's going to take on a little bit more heat above the temperature that it was when it first became a 100% vapor. So it gained a little heat by the time it got right here. So your TXV is measuring that superheat. It wants it to be somewhere around 10, 12 degrees.
Yeah.
Okay? So it's got a refrigerant charge in it, and this is just a capillary that goes to this power head right here. And it goes like this. It meters up and down, up and down. It's got a little needle inside of it that just meters that refrigerant. So as much as it needs to. So you've got 100% warm liquid coming in here. And when it first comes out, right here, it is about 80% liquid and about 20% vapor. Right here, at this point. Okay? So what's happening is that high pressure warm liquid is now coming out in a low pressure container, let's call it. This evaporator is a sealed system, so it's like in a container. So when that warm liquid comes out, it boils off. It's actually boiling because the pressure is so much lower that liquid is actually going to change state. Because think of it, it's under pressure, it's holding it like this. Then you put it over here and release that pressure. It just boils, okay? So it starts to boil off. Now it continues to change state all the way through this evaporator until it becomes 100% vapor. And then it goes back into the compressor, and this is a cycle. In HVAC, you typically have another fan right here, right? But in refrigeration, I mean in ice machines, you've got a water pump down here. And it's pumping water up here, and it's falling down the evaporator. And as this evaporator as this liquid is changing state, it's got water going over it.
Yeah.
Not air, not like an AC, it's an ice machine. So it's got water going over it, and that water is warm. It's room temperature, 70, 80 degrees here in Georgia. And as it's going over it, that heat is going in to this gas that's moving like this. So, you know, energy, you can't create it or destroy it. All we're doing is moving it around. Okay? So when that heat is entering in this evaporator, that is causing it to change state. It's a balance. You have to have just enough refrigerant, just enough powerful compressor. Everything has to be perfect. That's what the engineers figure out. It doesn't matter to us because they do all that. We just fix it and understand it. So they do have a perfect balance to where by the time that the vapor gets up here, it's taken all of this heat out of this water, and as that water comes down, it's down in this bath right here. It's down in this sump, and it's 32 degrees. Now it starts out about 70, 80 degrees.
No.
And through this process, it gets down to 32 degrees.
Yeah.
Well then, now 32 degrees is freezing.
Freezing, yeah.
But that's not ice.
Yeah.
That's 32 degree water.
Water.
Because we've taken out all of the sensible heat.
Okay.
Okay, that's just the heat that a thermometer can sense.
Okay.
But once we start putting it up over this evaporator right here, now we're taking out the latent heat. Okay, thermometer can't read latent heat.
Okay.
But it is a measurement of BTUs, because what latent heat is when you're changing state from water to ice, it's going to change it from 32 degree water to 32 degree ice.
Okay.
And then that 32 degree ice is going to be sticking up on that evaporator, and everything that's not ice is going to go back down here into the sump.
Okay.
Then it's going to pump it back up, and now it's right there at 32 degrees. So then when it comes back over that evaporator and it starts taking that latent heat out of it, it's going to change state as it's going down that evaporator, and it's going to stay on the evaporator. And everything that's not ice goes back down to the sump. And it does this over and over until the sump level comes down here and triggers a float switch.
Yeah.
Or you might have a probe that's up here that tells you that it's thick enough or whatever. And then at that point, that whole cycle is done, and then we go into a harvest cycle. And that's something that we're gonna talk about out there, hands-on.
Yeah.
You know, but when you understand this cycle right here, and then you see it happening out there on one of the machines, it'll just make more sense to you.
Yeah.
And I think that's good for this lesson right here. So we'll break for now.
That's always been crazy to me how